Prashant mentioned, today I'm going to give you guys a guest lecture on cloud computing and more specifically data center and cloud computing. Okay, so before we started talking about what cloud computing is, and I'm sure most people already know, we just want to mention what the data centers are. So basic data centers, you can think of them as a warehouse that hosts a large amount of servers on aisles, racks, and then it was like supermarkets if you replace all their goods on the shelf with servers, and that's basically what data center will look like from at a first glance. So data centers will have thousands of data servers that usually will also host like tens of hundred terabytes of data, especially in today's scenarios. Well, people use data like clouds or to do like data processing. So, like I said, the data center that built for a reason. Large enterprises use them as a means of host their own enterprise applications. Okay, the enterprise applications are used by people from that companies, and then for business use, but also very important aspects of today's data centers are also used by the internet based applications. Well, users are people's like us that was connecting to web service. So as you know that most of the internet big name companies like Google, Facebook, they all have their own data centers. And they like to host their own applications inside the data centers simply because it's easy for them to manage and then to scale up the resources once the user workload surges. And one of the very well-known internet applications that use data centers, more specifically the Amazon EC2s, is the Netflix, as many of you might be using them. So Netflix actually started up as a streaming company. They are very successfully expand their business to support thousands of millions of users across US or even abroad, just by simply using their Amazon's AWS service. And we're going to talk about that a little bit more in the later slides about cloud computing. So one very interesting aspect in their recent move is that they actually hired someone from Amazon in 2012, just simply because they're just using so much of the Amazon resources that they hire a very seasoned Amazon AWS engineer to like head their engineering team. Okay, so yeah, also applications like Pinterest and Expedias and all that web service you're using daily, they all hosted in data centers, or more specifically clouds. So as I said, they are used by either large enterprise enterprise companies or internet companies. But what are being used for? First of all, the most important aspects of the usage of data centers, of course, serving the users, right? So despite all their daily users that will actually go to the websites and then use the service, they also being used to do some big data analysis. Like users will like all this, big data like the genome project. They submit the data and then use like framework like MapReduce or stuff like that to do the data processing. And also one of the very important aspects is that like the industry like Walmart and other sales company that actually they want to like analyze the user data to actually get useful information about what you might want to buy and stuff like that. So before looking inside what is actually inside a data center, I just want to quickly mention what the traditional versus modern data center, the differences. So the key takeaway here is that the modern data centers are heavily virtualized. Okay, so the reason is that now the data center is actually dealing with more dynamic user workloads, and simply the way that the traditional data center build is not suitable anymore. Traditional data centers are built in a very static way that you just plan out where you want to build the data centers. You buy the amount of servers you want to provision inside the data center, and you almost never change until one day you get rid of it and then build another one. But as I said, that the modern in today's internet, it will have very dynamic workloads. So that's why virtualization is used as a means to actually manage the resources inside data center. So also with virtualization, it allows the system admins to do a lot of automatic maintenance and to maintain the whole data centers. So as I mentioned, the data center is just, you can think of as like a supermarket with all their shelves. And as you see, this is a picture of data center. It actually looks pretty much like a very crowded, warehouse that with all the goods, but instead of just servers. So, but one key point is that the data centers are not just servers. That's because there are other aspects that are as important to run the data centers. Like, think about the servers inside the data center just provide the power to processing power to actually that to use that systems. But in order to use that, you will have to have access to their electricities, and with thousands of servers turned on at the same time, you also need to deal with the problems of cooling. So, in other words, that data center is also the cooling infrastructure inside data centers is very important. So the cooling infrastructure, why is it so important? Because think about it. For $1, it's a very simple analogy, is that for $1 you use to power your server, you actually spend another $1 to cool it down, to cool the whole room down. So as in the money aspect, it is very important. But how do we actually manage the cooling inside our data centers? There are a couple ways. Very straightforward way will be you just want to reduce the amount of heat is generated by their thousands of servers. But you're saying, if people are using their servers, there's no way that we can actually do that. So that's where the virtualization comes in. Virtualization allows you to do a very cool stuff like server consolidation, which means that you can, when the workload changes, you can actually, migrate virtual servers to a big physical server, and just turn down the other, idle physical server to actually reduce the amount of heat. And also, researchers have been starting how do you actually efficiently cool down their data centers. There are a couple very successful use cases of people using cheap cooling methods, such as the water cooling. One example is the Holyoke green high-performance computing center that was co-built in the Holyoke. So the idea is that you want to use, instead of turning on the cooling unit like the AC when the temperature is above, like, say 80 Fahrenheit. You want to use the cheap energy as often as possible. And by one way to do that is just you build the data centers close to a, a water resources that you can use, nearby. And also so this is a very small scale that using the water to cool down the data center. There are very, very big tryout about using open air cooling, which the idea is just very simple. You just get through the cool air to the whole data center and cool it down. So Facebook has tried it in both their North Carolina and Oregon data centers. So the way they did it is that they will have so as the name suggested, you would just use the air to cool down the data centers. So very efficiently, by using these very simple methods, you can actually reduce the power usage. You can actually improve the power usage efficiency to something like 1.07, which is really good. Think about it as a number that just say how efficient you use the power. The lower number, the better. The best is like 1. That means, you just use the power to simply power up the server. You don't have any other, the energy is not used for something else. As I said, the data center is more than just racks of servers. There are, other aspects like the cooling I just mentioned, and also equally important is the power and backup. That of course, even the cooling use the power. So one thing about the data center is that you consider all these aspects. There are researchers trying to find out the best facility to build a data center. There are the aspects they will be considering will be the cost of building the data center, because data center will take a large amount of spaces, and then you want to find somewhere that real estate is cheap to build a data center. And also you want to have the cheap electricity bill, which you want to certainly be close to some transmitters, so power transmitters, so you can actually get the electricity from the grid really cheap. And as I said, temperature might play a very important aspect. You might want to build a data center in a cooler area so that you can actually use the natural temperature to actually cool down the data inside the temperature inside the data center. But all this has to play in a role to be taken into consideration in building a data center. But the most important part that people being considering where to build a data center is also where the users actually coming from. So you want to build a data center that is very close to the users. That means that you have very small network latency between the end users and the data centers, and potentially that could improve how the users are getting the service, the performance. So before moving on to talking about the modular data center, just want to quickly mention that do anyone want to guess how many servers a rack could hold inside a data center? Anyone? Just a guess? Nobody? 10. More than that? Maybe? Yeah, so basically the data center will have hundreds of racks of servers. A rack is basically, the very standard unit is 40 rack units, which a rack unit is basically something around 5 centimeters. It's like this. So regular servers, not like the desktop, we have some of them is of 1 rack unit. Some of them might be 2. Depends on the power of the server, and different server built different way. But usually the rack is 42 units. That means that it can hold 42 one rack unit servers. But mostly people don't actually hold up that many, just because the cooling issues. You don't want to stack server too close to each other. Yeah. Great. So, as I said, that data centers are racks of servers. But what is the efficient way to actually spin up a data center, you know, in like a month? I do not know how long does it take to actually build up a real data center like from scratch, but by using the module data centers, you can actually reduce the cycle from the purchase to the deployment to 6 months, which apparently is a very, very quick timeline already. So what is modular data center? Modular data center is just you can think of like a shipping container, but instead of containing all the goods inside, they're just rack of server. They're ready to use. They also will depends, but also they will consist of the cooling unit is already installed there. They have well-designed. The server is networked together using the cables already. So all you need to do is you buy one of these containers, and as you see that you can put it outside or inside a warehouse to actually use it. All you need to do is just add electricity. So it is basically a very convenient way for big data centers that actually want to expand their current infrastructure. So they'll actually have like a lot of company has this kind of service. So one of them is like Dell. They actually have this kind of service that will different flavor, but apparently that they will allow you to use their to build the 20 to 24 racks of server inside one module data center. So and then this whole process is usually 6 months, and the charge is ridiculous. But yeah, it just saves you some time. But well, yeah, you use the money too by the time, so it's very natural. Yeah. So before switching to the cloud computing, I just want to quickly mention the key technology that's used in today's cloud, today's data centers. So we've been talking about what a data center will look like, how the data center will be the location will be choose, and but one really key technology that actually enables today's huge amount of data centers that are being built and managed automatically is server virtualization. I'm sure you have covered this specific type of virtualizations already, but basically at a high level, server virtualization allows you to slice the physical server into multiple pieces that you can host virtual machines, which is just virtual servers. But appears as a server to end users. So virtual machine, like the virtual machine host inside the one physical server could have different operating systems, and then that allows you to do very flexible resource allocations. For example, that if let's say that you're doing more work in the Windows virtual machine, and you want to have allocated like 2 gig more RAM on it, and for example, if you are using a physical machine, all you need to do is just buy a slice of RAM and then plug it into your server. But by using the virtualization, then it's just simpler than that. Just push a button and your virtual machine will actually have 2 gig of RAM to it. So, and then you can also do the virtual machine migrations from one server to another to actually free up the space for their first virtual machine. Yeah, so that's the animation is done. Okay. yeah, so that's basically about it, about their server virtualization. Why is that still here? Okay. So as I said, the modern data centers heavily using the virtualization to enable automatic and to enable heavily automations to ease their manual interventions in the management of the resources. So virtual machine, or say virtual servers, actually are important because that allows you to do very cool stuff like consolidation. What consolidation means is that you would take, say, 4 old physical servers and you put everything inside this 4 old physical server to one big one, one new one in each spot. The reason is that servers will have a multiplication year cycle, like say 3 years or 5 years. Every 3 or 5 years, you want to replace your old servers with new ones, just simply because it's old or it's not as reliable. But as you also might know, that the hardware is actually upgrading in a very fast way. So the servers with the same amount of money, or even less, the server you purchased 3 years ago is not going to be the same server you're going to purchase today. Which means if you have, say, 10,000 servers inside one data center that you purchased 3 years ago, if you are going to purchase another 10,000 servers, you probably don't need that many, because you can just use probably 2,000 servers to satisfy what you were doing previously. So the idea is about the virtual consolidation is that you simply just virtualize all the things that are running inside the old physical server and put that into virtual boxes of machines, and you just move them to the new servers you purchase. By doing so, you can save some money, and also you probably reduce the heat, because you reduce the server from 10,000, say, to 2,000, right? So yeah, as I said, but the mapping is not easy to determine, because you don't really know what is the exact mapping model from the old physical server to the new ones. But so there are researchers looking at the ways of how to do very concise resource modeling from mapping the old physical servers power to the new ones, so you can actually calculate how many new servers you will need when you're trying to purchase. So that enables you to and also besides the cooling and electricity bill, it also gives you easy maintenance cycles, because now you only need to maintain 2,000 servers. And also the other important usage is that you're going to use virtual desktops that allows you to connect to the virtual machine hosted inside the data centers. The idea is that companies will probably, let's say, companies with 10,000 employees will probably do not want to buy everyone a very fancy computer laptops, even though you are doing some work on your machines. But the very important concern they're having is that the data leaking issues. They want to keep all their data inside their data center, inside their private data centers themselves. So one way they do it is that they will buy a bunch of very powerful servers, and they're going to use virtualization to slice them up, and they're going to allocate each employee a piece of them, and then they will give each employee a thin client, which is less powerful. And all you need to do is you just use something like RDP to connect to the server state, the virtual servers they give you hosted in the private data centers. So by doing so, they they can successfully control their data, the sensitive business data that they don't want you to get outside. But you can access it for sure, but you cannot get it out. And they have easy control of that. And also, like by doing so, they will be able to patch the system easily because they just centralize everything inside the data center instead of they need to go after you to get your machine to help you patch for the security hole like that was previously. Yeah. So and aside from the enterprises using this model, there's also a service that was hosting their virtual desktop in the cloud. It's called OnLive. So this company actually have this idea is that they want to have the Windows virtual machine hosted on their cloud, and while they have this apps on the iPad, and you would just connect to the Windows servers and do things that you will normally not be able to do using your iPad. And they don't only have this kind of service, they also have some like gaming. So this company is known as a gaming streaming company that they let users to play games on the cloud and using a video streaming to stream the game instead of rendering locally. But this company is no longer exist after this year, April 30th this year, because they just sold their patents to Sony. That's too bad, but that means people cannot just rent the games; they have to buy things. So we talk about various aspects of the data centers already. Now we're going to switch it to talk about what is the challenges nowadays that in managing the data center, as there are a lot of aspects like numbers of servers you need to manage and the electricity and stuff like that. One very important issue is that the resource management actually is a very key aspect in reducing the build of the data center. So how do you efficiently manage all the resources you currently have and you're going to have, and it is very important, which equally said that you do not want to buy things you don't need, and you do not want to have inadequate resources when you actually need it. So that is the term like in resource management is called over provisioning and under provisioning, which means again relate to the dynamic workloads that were faced by the application hosted in the data centers. Which means if let's say if you're a company that have heavy sales in Black Friday, and you will have a lot of users come and use your service. So do you just go out and buy 10,000 more servers simply because during that period of time you have 10 times more users visiting your website? Probably not. But what if they come visit your website and you don't have enough resources provisioned? Then service will crash and you probably cannot even check out, and the website is not responding, and all kind of things is caused by the resources not sufficiently provisioned. So again, these two scenarios are really bad. So there are being a lot of studies about how do you actually do it dynamically, which of course is not possible if you only have a very static set of servers. That's where the cloud comes in, and usually people would do is that they will keep a static set of servers to serve their daily traffic. But whenever there are a very large amount of traffic comes in, they just use the resource in the cloud to actually deal with the new service, to deal with a new workload. The idea is that you don't want to pay for random events that happening only once a year. You're probably better off just use other people's resources and just pay hourly. And we come to that a little later when we talk about the cloud computing. And also, energy efficiency is important, as I already mentioned. So we're going to skip that. The other very important aspect is the reliability. So there's a whole bunch of data, but I'm not going to go through it. The key takeaway is that think about if you have thousands of servers and at least one of them is going to fail is pretty much with a very high probability if you think of the failing as independent events, but even with, each server has a probability of failing, let's say 1% of probability, and you only need 500 servers for them to fail, for at least one of them to fail at a particular time. So, yeah, that's pretty much what it's about. So I want to come to the money aspects of the cost of data center, just give you more a better ideas of how costly your data center is and why people actually want to go to use the cloud resources whenever possible. So as I said, the NGH PCC is actually built in Mount Holyoke with other universities, and it is built. It's a very small data center. I don't know whether you guys have been there. I think pretty much they will schedule a tour there. You guys have been there, okay? So that data center, that very small, but it cost $18 million to build that one, and it actually take a lot of time to start and then build and actually for it to finish and up and running. Even now, I don't think a lot of server racks there is fully functioning yet, because simply because I actually don't know the reason, but I just know there are servers there still not running yet. So again, in this chart, we can see that it's actually a guy from this blog that actually did some analysis about how costly the data center is by breaking down the cost into a monthly cost between their server costs and cooling, power, and stuff like that. As you'll see that the dominant part is the server cost, but when you take another look, you will see that the power and cooling infrastructure is the red one is taking, let's say, a quarter of it, and power in the green one is taking roughly a third of it, a fifth of it. And then you will see that the point is that the server cost and the power cost is actually equivalent if you combine the green and the red one together. So it's about 1-to-1 ratio, as I said before. So it is a costly job to run this data centers. Not that's why people have been. That is one of the reasons that cloud computing has gained its popularity in the past, let's say, 10 years, because Amazon, when in 2006, it is actually when the cloud computing has actually become more active in 2006 when Amazon launched their first services. So it's been almost 10 years. So cloud computing actually, the aspect is because cloud computing can offer you cheap resources because they are large. They build large data centers. They take advantage of this economical scale aspect. They buy service in bulk, and they just they are running this as a business. So they have a business model to make it profitable. The thing is that if you're a small company, if you want to host the service somewhere, you probably don't want to go out and build a data center yourself. Simply, first, you don't have the money, and if you do, and as I said, the workload might be dynamic. You never will provision enough servers if you actually have more clients comes in, or what if your business fails and you probably will lose a lot of money because you build that data center. But so that's why people been using the resources in the cloud, just simply because they offer very cheap resources. So, what is the cloud? That is the question that could be answered in multiple ways. But the key point is that the cloud is basically that offers you the resources you need remotely. So clouds will be hosted some. You probably don't know. You probably don't want to know or don't know where the service is being rendered to you, but you know that whenever you need it, it's always there. And then they also have this pay-as-you-go building model, which means that you only pay for whatever the time you use, the amount of time you use in it, which means you don't have to. In some cases, you don't have to pay upfront fees, and you don't need to invest in buying the servers. All you need to do is that, okay, say I need a very powerful machine to run some experiments, and I just grab it and I use it for 2 hours, and then you just pay for that 2 hours. Or equally likely is that in the Black Friday, you just acquire a server for 24 hours, and then for user to use that time period. As I said, whenever you want the resources, cloud is designed in a way that they can actually provide the resource in a very reliable way. And also because they were built in, the cloud is built using the large amount of data centers that Amazon will actually have. I would say 11 data centers across the world. And so they give you the huge amount of resources at your fingertip. That is a tremendous scalability that you could ask for from just pay for very cheap. And then one very important aspect of this cloud is they sort of most of them actually use different type of virtualization techniques, and but most importantly, the reason they can offer you cheap resources because they multiplexing the physical resources, and you're definitely going to share resources with other people when you're using the cloud resources. So there are different flavors of a cloud service that is being provided today. One of the most important one that will render you almost equivalent to what you could actually go out and buy a physical server is called infrastructure as a service. So infrastructure as a service, so the one that the homework you're doing right now, the Amazon EC2 one is actually an example of an infrastructure as a service. They provide you the server, the virtual machine you're getting from them is basically, you can think of the local machine that you can do whatever you want. You can install you can install application in itself, and then you can run your code. You can use whatever language you would like to write a code and run it from inside the virtual machine. You can host a website using the virtual machine they provided. You can install and run MapReduce inside of it, whatever you want to do. Okay, so the point is very the distinguish between the virtual machine they provided to you is equivalent to whatever the server you will get from the outside. You go out and buy it. And equivalently important is one service that called platform as a service. Basically, the Google App Engine that allows you to write a code using your APIs and upload it your code there, and they're going to run the code for you. You don't need to worry about, what if people use your service more, and what if the service is going to crash, stuff like that. The platform itself is actually taking care of the scalability for you by scaled it up for you using the sandbox. But we're going to talk about it a little later, more when we go to the next slide. So yeah, I didn't mention the other one, software as a service. This is very this is just very I don't know. This is more common in the enterprise settings. Like for example, that you will want to use some analysis tools, the softwares that you probably don't want to buy the license, and you just pay to use their software for once or something like that. Like Gmail's app is not the same as what we use the Gmail, the web client is. It basically allows you to, the mail servers stuff, and then you can just pay monthly fees to use it. So, okay, so just wanted to talk about the Amazon EC2. As I mentioned, that EC2 offer you the very cheap resources that also comes in different flavors of, power and storage capacities. So the smallest, actually the data is a little outdated, but the smallest virtual machine you can get today is actually costs 20 cents now. So it is 10 times more than it is here. I don't know, this inflation, whatever the term is. But the idea is that they offer you the resource very cheaply. They come in different sizes. And the largest server today is actually weighs like 240 gig and then 6,000 terabytes of SSD and let's say 32 cores. And you pay like $6 for it. But no big deal if you think about the 6 terabytes of SSDs actually cost you, let's say, $3,000 maybe. This price here is actually what is offered as a on-demand servers instance in Amazon, which basically means that whenever you need a instance, you just go to Amazon and say, hey, I want this type of server, and they're going to give it to you. And once they give it to you, it's you they are responsible to turn it off. Amazon will not be able to take it back when they actually need it. But so once it's allocated to you, the point is it's never going to delocate it. So you actually have access to the on-demand servers whenever you need it. But so this is a price for that. But there are other pricing options that are offered by Amazon that's also equivalent interesting. For example, as I said, once it is allocated to you, Amazon is not going to take it back if you use this on-demand price model. But things just happen if they don't have enough resources. They're not going to allocate the server to you, and then simply because they just don't have that many server provision. So one of the pricing model they use is called I forgot the term, but basically the idea is that you pay an upfront fee, let's say like several $100s, then it guarantees that whenever you actually want a server, you'll get it for sure. That's because Amazon wants to provision how many servers they actually going to purchase by simply saying, okay, how many customers I'm going to for sure going to get. Otherwise, Amazon's going to provision too many resources without people actually going to use for it and pay for it, and they're going to lose money, right? So come to the resources they actually leftover resources in Amazon scenarios is that even they do this upfront pay sometimes, people are, the resource is still going to be idle inside data centers. So for sure, they're going to turn it off so that they will reduce their heating bill. But still, they want to make sure that the resources are used in a way that they can actually benefit, because they run it as a service, right? So how do they do that? Is that they in 2009 they come up with a new pricing model that is called spot instance market. So what spot instance market do is that they basically gather all these resources that are not being used. So they build a market that you can bid on the resources that you're going to get. So basically, let's say, I'm pretty sure not a lot of people will want a very powerful servers all the time. So, but Amazon still have them. But if it sits idle, it's going to be cost a lot of money, right? So what they did is that they do this second bidding strategy, which means they have a set of price for their instance. For example, let's say the large one here, it is on demand, it's $2 per hour. They say, okay, at this point in time, I offer you the prices is, let's say, 20 cents. Okay, so you're going to get these resources if you bid more than 20 cents. Okay, so that gives user a very cheap way to utilize the resources, in a way they're not going to get if the price is $2. But the thing is that the spot instance prices are changes only based on the supply and demand. That said, if more people are going to request the on-demand server or on-demand large server, or the spot prices are actually going to go up, and your instance is going to get revoked by the Amazon, because simply there's no guarantee in the resource they give it to you. They just provided that means that they can take it anytime whenever your bid is actually go below the price for the instance. So this is a very interesting topic, as people have come up with different bidding strategies. How do you bid based on their spot history, price history? What is the most profitable way that you can actually bid resources that you can use for the least cost and the highest availability. Because again, spot instance can be revoked at any time when your bid price is well below their spot price at the current time. So this is a very good model that Amazon is using to actually sell their not redundant, but idle resources, so that this whole ecosystem is actually maintaining as a very, it's getting the money they need to actually running. Okay, so also before we switching, we also want to talk a little bit more about the platform as a service. More specifically, today is more about Google App Engine. Just don't look at the slides, there is some outdated information there, but basically the platform as a service allows you to actually submit your code, like I said, using their API, and then they were going to run the code for you. You as a developer only need to write the code, and you don't need to worry about the maintenance and scalabilities as you need to. So previously, when Google App Engine just was introduced, it only supports 2 different languages, which is Java and Python. So you have to write. So basically, the way they did it is that they run this platform as a sandbox, and they will have all the language runtime and the web server and your code together in this sandbox. And what they need to, since they have this language runtime, constraints, so they basically restrict some levels of access to to the underlying operating systems, such as you sometimes don't have the direct access to the file system, which could be a little annoying when you are doing development. And also one very annoying aspect is it only supports Python and Java, which apparently is not enough, right? So because there are a lot of people, especially for the web service, and a lot of people are writing code in PHP, and now the Go is one of the very popular languages people use to develop the distributed applications, simply because the way how it is written and is very easy to scale. So the Google App Engine is evolving, so they actually have this support for 2 more languages, which is PHP and Go, simply because they're just so popular. And then, yeah, this is the reason I suspect. I actually don't know why they actually added. So my suspicion is this is just the demand for these 2 languages are so big that they have to support these 2 languages. So by doing so, that you can now write apps in 4 different languages, and you just submit the code there, and things just works. But still, it's not ideal, because if you think about the infrastructure as a service, that the virtual machine you get from Amazon, you can basically write code in whatever language you want, and you just you can host the service from that virtual machine, regardless the language you chose, right? So one way that the Google App Engine is trying to compete is that they have this idea of that called managed virtual machine. The idea is that instead of giving you a sandbox that you're going to run your code in, that poses a lot of restrictions in terms of languages and what else then, and the restricted access to some low-level system calls. They give you this virtual machine that is just exactly like what Amazon's going to offer you. So the virtual machine just relax for what the Google App Engine is providing to you. You can now just do whatever you want, use whatever language you chose, and is equivalent the same idea as the Amazon. I don't know whether they're competing in this field, but apparently the Google App Engine is quickly shifting to the way that they want to get all the business. But again, this is how Google works. So they also, one thing about the Google App Engine is that Google, as you know, have a lot of cloud servers. They develop like the databases and the MapReduce frameworks and stuff like that. That by using their app engine, you can actually just simply integrate it to your app, the code you wrote by calling the API, so you don't need to manage the database stuff like database yourself, and you just simply use the database hosted in a cloud, in the app by the Google App Engine itself. So so that's pretty much about the different cloud service that's offered, like software as a service, platform as a service, and infrastructure as a service. There are other types, but they are not as popular as these 3. So for now, we also, so far we have been only talking about the public cloud, which is the Amazon offering, which public cloud is basically, the idea is that they offer you a service and you pay for it, right? So they are there as a reason to profit and make money. However, the enterprises, big enterprises, they don't really comfortable with all the public cloud service that are provided, and they don't really want to host their sensitive data in the public cloud, just because the security issue they are worried about, the data leakage, and the competitions, and competitors stealing that data, and a cloud is not a very safe place. And also, it could be happening that people will steal your data in the rain and stuff like that. It's just very dangerous. So yeah, so the way people dealing with this is that they still use the cloud, but instead of the public cloud, they use the private cloud. So the concept of private cloud is the same as public cloud, except that the data centers, that the cloud data centers is actually only being used by single enterprises. They're not going to share the resources with any other people, simply because the worry about the leakage. And also the private cloud is usually smaller compared to the public cloud. Well, that's just simply because not a lot of people are using. Yeah, no, that's not true. But the private cloud is smaller. It's simply because they have the way that private cloud is designed to only be functioning as a very core of the enterprise, and they want to host their sensitive data and very critical application in the private cloud, but they still want to use the public cloud for stuff like the sudden increase of workload they're not be able to deal with. So they're going to have all their edge service, mostly edge service that hosted in the cloud that is not as sensitive. One way to do this is that they combine these two models and doing a hybrid cloud, which means just like I said, which means that when the workload increases, they're going to transition all their the requests to the public cloud by using their resources. One technique that's being used is called cloud bursting. The idea is that you run whenever possible using your free in a sense that you don't need to pay hourly, but you still pay a lot of money when to bring it to work. So you use your free private data centers, but switch to the public pay as hourly usage whenever the workload increases. Yeah, this is for the cloud. There's programming models, different program models. They're going to be suitable for different type of applications, and as mentioned, the spot market render you very cheap resources, and is now a very good resources for people who are doing big data analysis. Simply because you only pay a tenth of the cost for the resource you're getting. So a lot of people are taking advantage of it because sometimes you don't really care whether you get the machine at this point or the next hour, as long as the job finished, say before your meeting tomorrow, right? People are using this as people are using spot markets to do this analysis. So it's actually enabling a lot of very powerful way of dealing with the data like people have. Yeah, but the one way to worry about to be cautious about is that the spot markets could revoke your instance. So you probably want to checkpointing your the application states periodically, so that you will not face some fatal loss at the very last minutes of the application. Yeah. Lastly, I want to talk about the challenges in today's cloud. It's very similar to what the data center's cloud is. Simply because cloud is, in a way, data center. Cloud is built using data center, and data centers, and they probably use couple data centers in different locations. So the changes is the same. So we haven't talked about what is the privacy and security issue that is actually imposed by the cloud in detail. But we're not going to talk about it because it's not relevant to our topic today. But one thing that to keep in mind is that you probably don't want to keep your sensitive data in the cloud, as most of the enterprises are keeping their business secret. And the tens of thousands of machines that are used by the cloud, they also pose a very big questions about the scalability, which is how do they actually manage all this, machines efficiently? Again, it is the same as what the data center is. That you want to do good provisioning. You want to know how many servers you're actually going to need. But for cloud, it's a little bit tricky because you are now providing a very fixed service. You probably don't know how people are going to request a virtual machine and how they're going to use it. You certainly can analyze it, but it's never going to be enough. So that's why the smart markets is a very good way for clouds like Amazon to deal with their idle resources. Again, the how you programmed in an efficient way that you can actually use a class of nodes that to do things you want. Like recently, the Spark as another new MapReduce-ish stuff that was being introduced, and they actually use a cluster node. They can deploy whatever the code you wrote parallelly on multiple nodes by using automatically by using the script to set up the Hadoop file system for you, and then copy all the data around, and then do stuff for you automatically. So it provides a new very similar to MapReduce, but the new programming model and styles for you to actually doing big data analysis in a way that you can probably finish the job sequentially. If you do it one machine for 10 hours, say, using 1 hour of 10 servers, you can quickly finish it up. But again, it's nothing compared to hosting a service that spans 10,000 servers. Like most of Google's core servers are actually use tens of thousands of servers, and how do they actually manage all this reliability issues and stuff. Okay, so this is just further resources about what we've been talking about today. There's conferences that are that mainly focus on the cloud, although the SOC is slightly, it's called Symposium on Cloud Computing, but it's slightly shifting to Symposium on MapReduce, I guess, because the paper accepted every year is just all data processing and MapReduce framework. But still, it's a very good venue for cloud computing, and there are a bunch of other system conferences. They will pretty much have a track about the cloud computing, mainly on resource management and efficient green data center, or network efficiency inside the data centers. So yeah, if you're interested, and you can take a look at the venues, and there are of course the Google and Amazon's blog. They keep posting the newest technology and service they launched, which is very good. And Above the Cloud is one of the first paper I read when I started grad school. So this is a very good survey papers in 2009. It talk about various aspects of clouds and what is the challenges, and it gives you overviews of things you probably want to know in a high level about either doing research in the whole data center area in general, or just want to get a grasp of what what it looks like to do research in cloud computing. Okay, I think, yeah, that's basically about it. So anyone have any questions? Great, so don't forget to do the homework, due, I believe, April 24th. And if you have questions, email the TA or the professor himself. And thank you so much for today's lecture. That's about it. Thanks.